This is Navin, PGT Chemistry TS Model School. In this video, I want to tell about line spectra of hydrogen atom. First of all, we have to know about spectra, or it is also called electromagnetic spectrum. So, what is electromagnetic spectrum? Let me discuss. When a charged particle is vibrating, it generates the electric field, and due to that electric field, the magnetic field also generated. So, when a charged particle is vibrating, the electric field is generated, at the same time the magnetic field also generated, and these two fields are perpendicular to each other. So, the electric field and magnetic field both are perpendicular to each other. See, the red color lines shows the electric field and the blue color lines shows the magnetic field. When a charged particle vibrates, they are generated and they are perpendicular to each other. See, when we throw a stone into a pond, we will observe the ripples, and these ripples are moving along the direction or along the surface of water in a wave motion. In a wave motion, the ripples are waves, ocean waves or pond waves. They are moving in wave motion. In the same way, when the charged particle is vibrating, the disturbance is generated, and the disturbance is moving around the charged particle or around the vibrated particle, and it is also having the wave motion in all directions, and electric field, magnetic field generated, and they are perpendicular to each other, and they are called electromagnetic radiations. So it includes gamma rays, X-rays, UV rays, IR, microwave, FM, AM and radar, and these are the visible light, WGR, rainbow. So these are all called electromagnetic radiations. And what is electromagnetic spectrum? Electromagnetic spectrum nothing but the arrangement of electromagnetic radiation in the increasing order of wavelength or decreasing order of frequency is called electromagnetic spectrum. So, the increasing order of wavelength or decreasing order of frequency. Wave means it is having one crest and one trough. This is called crest, this is called trough. So, the distance is called, this is the length of wave, so length of one wave. So from here to there, the wavelength increases, means the wave is like this here, and here the wave is like this. See, here the length of wave increases, wavelength increases. Gamma rays having lesser wavelength, and radio waves having greater wavelength, more wavelength it is having. When we arrange these electromagnetic radiations in the increasing order of this wavelength or decreasing order of frequency is called electromagnetic spectrum. See, a small portion which are rainbow, this is a small portion of electromagnetic radiation. It is also called a spectrum, and this spectrum is called visible spectrum. And these radiations we can see with our naked eye, but remaining radiations we cannot see with our naked eye. These gamma, X-ray, UV radiations they are not visible to our naked eye, but only 7 colors are visible. They are called WGR, and it is also called. When we arrange these colors in the increasing order of wavelength, and this is called a spectrum. This is a visible spectrum, and complete this one is called electromagnetic spectrum. See, this is a electromagnetic spectrum, and the colors are visible colors. So that is a visible spectrum, and total is called electromagnetic spectrum. Visible spectrum is a part of electromagnetic spectrum. See, these are the wavelengths of every radiation. The wavelength here is in meters, and here 400 nanometers to 750 nanometers. This is the visible light. We can see these colors, and remaining colors we cannot see. And the spectrum mainly of two types. One is line spectra. See, line spectra of hydrogen atom. One is line spectra, another one is band spectra. Line spectra is also called atomic spectra, and band spectra is also called molecular spectra. What is line spectra? And it is generated due to the excitation and de-excitation of electron. When the electron jump from lower energy level to higher energy level is called excitation. When the electron jump from higher energy level to lower energy level, that is called de-excitation. In this process, the spectra, when we record the radiations or wavelength, we will get a spectrum. The spectrum is called line spectra. So line spectra is due to the excitation and de-excitation of electron, and band spectra is due to the rotation and vibration of atoms in a molecule. So due to rotation and vibration of atoms in a molecule, the band spectra is generated, and due to the electrons excitation and de-excitation, the line spectra will form. And one more classification also there: emission spectra and absorption spectra. So when the electron jumping from lower energy level to higher energy level, it absorbs some amount of energy in the form of radiation. So when we record that absorbed energy, on a detector, we will get a spectrum. That spectrum is called absorption spectrum. And when the electron jump from higher energy level to lower energy level, it releases energy in the form of certain discrete wavelengths, and when we record those wavelengths in a detector, we will get a spectrum. That spectrum is called emission spectra. So this is the hydrogen spectra. Now we are discussing line emission spectra of hydrogen. Line emission spectra of hydrogen. And remember, this is the simplest spectrum compared to the all spectra. Why? Because hydrogen having only one electron. So this is the simplest spectra compared to the all spectrum, and it is very unique in nature. The line emission spectra is a unique in nature. Every element shows a characteristic line emission spectra. Like our fingerprints, we can easily identify the human being. In the same way, by using the line emission spectra, we can easily identify the elements from unknown compounds. In emission spectrum, we will get the bright lines on a dark background. In absorption spectrum, we will get the dark lines in a bright background. Now coming to line spectra of hydrogen. Hydrogen atom having only one electron, and the electronic configuration is 1s1. So it is having only one electron, and that electron is present around the nucleus in first shell. That electron is present around the nucleus in first shell. This is the representation of cell. N equals to 1 means this is the first shell, second shell, third shell, fourth, fifth, line so on. The energy of the shell increases. As the number increases, energy of the shell also increases. Number increases, energy of the shell also increases. So here it indicates increasing in energy. Hydrogen having only one electron. So this is the simplest line spectra. When we take or consider a certain amount of hydrogen gas, when we heat that hydrogen gas, or when it is subjected to light, when it is heated or when it is subjected to light, the electrons which are present in the hydrogen atoms absorbs different energies. Why it absorbs different energies means when we heat the hydrogen gas, the hydrogen gas near to the flame absorbs more energy, and the hydrogen gas which is far away from the heat absorbs less energy. That's why different electrons in hydrogen atom absorbs what? Different types of energy. After absorbing energy, they jump from lower energy level to first, the all electrons are present in first orbit in each and every hydrogen atom, but after absorbing energy, they jump from first energy level to different higher energy level. This process is called excitation. But they cannot stay there for a long time. Again they come back to the original first energy level by absorbing or by releasing some amount of energy in the discrete wavelengths. By giving some specific wavelengths, they come back to the original energy level. So when we record those specific wavelengths on a detector, we will get a spectrum. That spectrum is called what? Line spectrum. When the electrons come back, the excited electrons come back from any of the higher energy level to lower energy level. For example, the electron is in first. Now it jumps from first energy level to seventh energy level. Now the electrons, some of the electrons are here in seventh energy level. Some of the electrons are in sixth. Some of the electrons are in 5. Depends upon the absorbing energy. They jump from this energy level to different higher energy level. The electrons which are giving less amount of energy, they jump from 2 or 3. Which are absorbs more amount of energy, they jump to 6, 7, 8 and so on. And the electrons, the excited electrons, some of the excited electrons come back from any of the higher energy level to lower energy level 1. For example, electron is in 7th orbit, it come back like this to the first element. From 7th to 1, it releases some amount of energy. That energy we can detect on a detector, we can collect on a detector, we will get a spectrum or spectral lines. And the electrons which are present on 6th, they come back like this to F. Some of the excited electrons from any of the higher energy level to lower energy level 1, some series of lines are formed from 7 to 6, 7 to 1, 6 to 1, 5 to 1, 4 to 1, like and so on. So all the excited electrons come back from the different higher energy levels to lower energy level 1, a series of lines. Each electronic transition gives one line in the spectrum. So these we will get a series of lines, and we given one name also. The series of lines is called Lyman series. Lyman series. And some of the excited electrons come back from any of the higher energy level to lower energy level 2. A series of lines formed. Means from here to here, second level. From here to second level. From here to second level. From fifth to second. Fourth to second. Third to like this. So here the series is called Bohr series. Bohr series. In the same way, from any of some of the excited electrons from any of the higher energy level 2, they come back to the lower energy level 3. A series of lines formed like this. This is called fashion series. In the same way, next two series is also formed from the higher energy level to lower energy level 4. Bracket, and one more series is fund, bracket and fund like this. From any of the higher energy level to lower energy level 1, Lyman series, lower energy level 2, Bohr series. If they come back to third energy level fashion, fourth energy level bracket, fifth energy level fund series is formed. And in Lyman series, it is formed in the UV region, and Bohr series is formed in the visible region, and remaining are formed in the higher region. Means the releasing radiations are in the UV region. The wavelength of these radiations in the UV region, only we can see the series, Bohr series we can see. Why? Because this is in the visible region, 400 nanometers to 750 nanometers. That's why we can visit these radiations are visible, but remaining all series we cannot see. And the de-excitation process may be taking in a single step or in several steps. Means, let me take one electron come back from fourth energy level to first energy level. It may come back directly from fourth to first in a single step or in multiple steps also possible. Means this is the direct step, step 1, and step 2 maybe in multiple steps. Maybe it come from 4 to 3, 3 to 2, 2 to 1, or 4 to 3, 3 to 1, or 4 to 2, 2 to 1, like this. The de-excitation process may be taking in a single step or in several steps, and each electronic transition gives one line in the spectrum. That's why we will get several lines in the hydrogen spectra, hydrogen atomic spectra. See, this is the hydrogen spectra of line spectra of hydrogen atom. First one is emission spectrum. We will get the bright lines on a dark background, and second one is absorption spectrum. We will get dark lines on a bright background. See, the length of the lines is same either is in emission spectra or in absorption spectra. That's why each element shows a characteristic line emission spectra. By using that, we can easily identify the unknown atoms from a unknown compound. This is the line spectra of hydrogen atom. Thank you.